My name is Molly Simons. I am the Marketing and Program Development Fellow for CCHRC. And thank you so much for joining us tonight for our first class in our clean energy series, Heat Pumps, Heating and Cooling in Cold Climates. We have two more classes in this series, one about solar power next Tuesday the 15th, and one about biomass energy the following Tuesday, October 22nd. If you want to learn more, you can head over to our website at cchrc.org, or I think we're going to put the link in the chat so that people can get there quickly. And all of these classes are generously sponsored by Golden Valley Electric Association. We are going to have a question and answer section after the presentation. So if you have a question, feel free to put it in the chat or save it, and we will get to all of the questions at the end. So our instructor today is Dr. Diana Fisler. Dr. Diana is an experienced building materials scientist turned entrepreneur who is interested in the interface between early building technology innovation and corporations that bring these technologies to market. She is the CEO of EcoSnap, an organization that is dedicated to making heating and cooling solutions affordable for everyone. We are so excited to have Dr. Diana here with us, and we can't wait to learn from her. So thank you so much for being with us.
Thank you for that kind introduction. It's great to be here. I'm going to go ahead and share my screen. And I'd like everyone to verify that they can hear me and that you can see my slides. Just give me a nod. That'll do. Okay, great. So thank you for inviting me. You heard my introduction. I'm going to talk to you today about heat pumps with a specific emphasis on how they perform in cold climates like yours. I sourced some of this presentation from presentations from NYSERDA, that's the New York Research Association, and Phil Kaluza, who is also one of the instructors here occasionally. So I rely on the expertise of others for some of the sources of this data. So you all Alaskans have a lot of great choices for heating. You've been at it a long time. You've got oil stoves and forced air gas furnaces. You've got wood stoves. Today, I'm just going to talk about heat pumps, and I want to show you that heat pumps are a great option under the right conditions. There are certain considerations for how to use them, choose them, and maintain them, and I'm going to share all those with you, along with an intro to how they work and what the basics are. And to frame this all, in general, a home's heating system is responsible for 50% of a home's energy use. And then water heating is another 15 to 25%. So this is an important thing for us to consider what the best solutions are. How do we stay warm and safe? How do we stay comfortable? And how do we do it economically? So to begin with, I'll talk about the basics, how a heat pump works. So a heat pump is basically the same technology as an air conditioner or a refrigerator. And we've seen those for years. And when in the case of an air conditioner or refrigerator, you are taking the heat, grabbing it, and pumping it outside into the outside air and releasing it there, making it cooler either inside the fridge or inside your house if you want it cooling. A heat pump can basically use the exact same technology to do that in reverse when you ask it to do so. So it has a little reversing valve in it. I'm going to get into the details a little bit. And so in the winter, when it's cold, it can actually grab heat from the outside and push it into your house, and then the air blows over it, and that's how it delivers it into your house. And sometimes people ask, well, if it's really cold out, how is it possible to get heat out of that cold air? But there's always some heat in the air, and heat pumps are really efficient at grabbing that heat, concentrating it, and transporting it into your house. So the key thing to know here is that heat pumps don't make heat, they move heat. And because of that sort of magical technology, they can actually be more efficient than 100% efficient. Most burning of things to create energy can only reach 100% efficiency, but heat pumps can reach 200%, 2, 3, 4, sometimes 500% efficiency. And it's through the magic of moving heat from where you don't want it to where you do want it. So here's just an example. So you see a heat pump, and it's some electricity is being delivered to the compressor of the heat pump. It's drawing some heat from the cold outdoors, delivering it into the warm house. And I'll tell you a couple of terms that have to do with heat pumps, but one of them that's going to be really important to talk about is the COP, or coefficient of performance, and the ratio of how much heat is delivered into the house to warm it to how much electricity was required to make that, oh, sorry, move that heat, is called the COP. And so in this case, it's 2.5 units of heat are delivered into your house to make you warm for every 1 unit of electricity that is used. I won't go a lot into refrigerants, but the key magic in this delivery process is the vapor compression cycle. Some fluids and gases are at they change states at exactly the right temperature to be really helpful at being able to be compressed and delivered where to different places. And when you compress gases and liquids, they get hotter, and when you expand them, they get colder. And so when we manipulate this cycle, we can put heat where we want it to be. So I'll talk a little bit about what's going on right now. So heat pumps have been known for a long time in more mild climates, but they had been thought 10, 15 years ago not to really work in cold climates. And we know that's no longer true. There's new technologies out there that are capable of delivering heat all the way down to minus 22 degrees or lower. A couple of trends that are driving people's interest in heat pumps. One is that the electric grid is getting more efficient, and there's more renewables, solar power, wind power, and other kinds of renewables on the grid. And switching from fossil fuels not only allows you to rely on that cleaner grid, but it also reduces pollution impacts. And the efficiency I just talked about, if you look at an oil heating system, it can only approach 100% efficiency. You can only get as much heat out of it as is contained in the fuel. But because a heat pump is using pumping to deliver heat, it can reach efficiencies well above 100%. The other thing that drives people's interest in heat pumps is that even in very cold climates like Fairbanks, sometimes it's hot in the middle of the summer when the sun is low and it's beating down and it never goes down. It can get pretty hot. And if you have to keep your windows closed because maybe there's poor air quality or a fire, a little bit of air conditioning can be a very nice thing. And so many of these things are what is driving people's interest and adoption of heat pumps today. So now I'm going to talk about maybe a little bit of terminology. So the first one I want you to know about is air source heat pump. And the acronym we use is ASHP. And what that means is you're grabbing the heat from the air outside. So a couple of versions of that. There are things called mini splits, which is one condenser on the outside and heads mounted on the wall or concealed within the wall. And that allows for conditioning of small spaces, maybe small open plan homes, or one shop or bedroom or hunting cabin where you need it to be conditioned. And then in contrast to that, another type of air source heat pump is ducted. This is where you have forced air throughout your home. And then the heat pump would be in the place of or next to the gas furnace, and it takes advantage of the ducting to distribute air throughout the home. In contrast to that, you may have heard about air to water heat pumps. These are not as common in most of the US, but important to know about because many people need them for the way their home's set up. And these are where you're still grabbing heat from the air, but you're putting it into water. And the big advantage to this is that you can use radiators or underfloor radiant heating, and you can also use it to heat your domestic hot water. I've seen a couple of these around at various events in Alaska. They're just starting to become introduced in the US and become more available. And then finally, the thing that I find people asking me a lot about is ground source heat pumps. And I'll talk to you about why those are terrific and why sometimes they're not the right choice. But in the case of a ground source heat pump, rather than grabbing the heat from the air, or in the case of cooling, rejecting the heat to the air, you actually use the ground itself or water within the ground or a pond nearby. You'll still call it ground source heat pump if it's a pond, as the place where the heat is drawn from and where it is rejected to. And the reason that that's a great idea is because once you dig down just a little bit, the ground stays at a relatively even temperature all year round. If you've ever been in a cave or something like that, you'll know that it stays pretty mild down there most of the year. So if you can access a ground source, a water source, it can be a very efficient way of finding heat and moving heat from where you want it to where you don't want it to where you do want it. Here's a couple more terms that you'll hear thrown around when you start really getting into heat pumps and when you start selecting a heat pump if you choose to do so for your home. One is HSPF, heating seasonal performance factor, and this is the efficiency of heating across the heating season. And the higher the better, the higher the more efficient. And the two, when I've put a slash here, is because there's recently been a change to the methodology for measuring these things. It's not something that you need to pay a lot of attention to, but if you're comparing two heat pumps, make sure you're comparing the twos to the twos and the HSPFs to the HSPFs. SEER generally measures the cooling efficiency across the cooling season. So how good is it at air conditioning? And then COP, I already gave away what that means. It's the coefficient of performance. It's the ratio of the energy out or the energy delivered to the energy that you have to put in to achieve it. And we generally want to see a coefficient of performance between 2 and 5. But I'll show you in a couple of slides that sometimes when it's extremely cold out, some heat pumps lose performance more than others, and you may end up with, at worst case, something like a COP of 1. But remember, a 1 means 100% efficiency. So it's already as good as burning gas for heating or fuel or fuel oil or wood. So the worst that a heat pump ends up being, as long as it's still working, is a 1. And then capacity. We typically, when we're in the deep south and talking about air conditioning, people will often throw around the word 1 ton or 2 tons of cooling. Here in heating climates like Fairbanks, we'll typically talk about BTUs per hour, and 1 ton is 12,000 BTUs per hour. And that's the total heating performance of the system. And a rule of thumb people like to use for a normal space that's not super well insulated is that a 12,000 BTUs of capacity can condition 450 square feet of living space. So keep that one in your mind. So when you think about that, then how big is your home? Is 36,000 BTUs of heating enough for it? Or could you do something like make it better insulated, improve the drafts and stuff like that, and get away with less heating performance? And these are all important things to understand about your home and about the equipment that you're evaluating. I think I have already covered that. So we're going to move on. So I kind of alluded to this already, but the one thing to always know about an air source heat pump is that as the temperature goes down, the amount of BTUs that heat pump can deliver does go down. That's a fact of physics. There's less heat in the outside air that's available, and there's not much to be done about that. So what's important to do is to look at that performance at low temperatures, and all of the heat pump manufacturers will disclose that performance usually at 5F, and they're starting to disclose it even lower. And look at that low temperature performance and ask yourself whether that performance is enough for your home, or are you going to need some kind of backup? And that's what you can expect when it's getting very cold out. And then the COP, of course, goes hand in hand. The lower the temperature, the lower the coefficient of performance. But look at what I mentioned to you before. You see how at moderate temperatures, it's up above 3. And then as it goes down, it approaches 1, but it never really gets as low efficiency as burning a fossil fuel in your home because of the nature of it moving heat rather than delivering heat by burning fossil fuels. And then just a quick visual for ground source heat pumps. This is, a typical ground loop. So it's buried in the ground deep enough that it can access the moderate temperatures of the ground and be able to draw heat from there or reject it from the ground. All of which is to set you up for this graph, which I want you to understand. A ground source heat pump, because it's drawing from a ground or a body of water, it doesn't lose performance as the temperature goes down because the temperature of that source stays consistent all the time. An air source heat pump will reduce inefficiency as the outdoor temperature goes down. And then just for contrast, electric resistance, a space heater or something like that, always has a coefficient of performance of 1. For every unit of electricity you put into it, you get 1 out. So you can see where the trade-offs here are, right? You might say, oh, then I would always want a ground source heat pump because it looks like it's better all the time. But I'll tell you a little bit about the drawbacks of that. And it's really around cost because digging up your yard or drilling a deep well or accessing a pond is not always really feasible. And it can cost tens of thousands of dollars to put in ground source. So what we often see is something like a new church. And so in fact, a church in my area put in a ground source heat pump. So if there's enough need for capacity to justify the cost of a ground source heat pump, that's typically where you'll see people putting ground source heat pumps in. In contrast, air source heat pumps are typically much more affordable. And so that's the reason that we trade off performance versus cost. Okay, so now that's the basics of how they work. I hope that was clear. If it's not, you can yell at me in the chat and we'll talk about it after I'm done. Now I want to go through some of the economic decisions that you want to make. So there are considerable benefits to homeowners for adopting heat pumps, and they're not all about cost. I've touched on these a little bit, but one is cost savings, and I'll lead you through a thought exercise about when you actually can obtain cost savings from a heat pump. But the other sort of unrecognized benefit is resiliency, fuel cost stabilization. If you have, say, let's say, a fuel oil stove and you put in a heat pump, now you have 2 ways to heat your home. You have resiliency in case you run out of one of those things. If the power goes out, you've got your oil stove. If you run out of fuel oil, you've got your electric. And you can switch between those two for the greatest economic benefit in your home. So that's a hidden advantage of different sources of fuel. And then the free cooling. Maybe you wouldn't go out and put an air conditioner in your home in Fairbanks, but if it comes along for free with the heat pump that's helping you defray costs and control your energy costs for heating, then that's a pretty nice advantage to have and increases comfort. I mean, especially for vulnerable folks that are maybe older or little babies, that it's too hot to get them to sleep in the middle of summer. It's a significant, nice benefit to a heat pump. I think I touched on the third point when I said resiliency. There are risks to burning fossil fuels in your home. There are some nasty byproducts to combustion, CO and NOx and things like that. By using a heat pump, you can reduce those risks. And then finally, on the economic front, there are some significant tax credits and rebates that I'll present in the next slide that can really defray the cost of a heat pump, especially if you are low income. There's some very attractive rebates that are either in place or coming soon that can make it sort of a no-brainer to put in a heat pump in your home. Okay, so here's just a partial list of some incentives that are out there. And I'm always revising this, and I'm glad to talk about them at any point. But utilities across the country are incentivizing heat pumps, and these are just a few in Alaska that are doing it. I don't believe Golden Valley is currently offering a rebate for heat pumps, but they've told me that they are considering it, and so I would expect to see that coming soon. And there's just a few different things, like usually a utility will have a requirement that the heat pump be at least a cold climate heat pump, if not a super extreme cold climate heat pump with very good heating performance, HSPF2 like I told you before. There's also a tax credit that's been in place for quite some time. You have to file your income tax in order to claim that. It's called the 25C. And then the big thing that's coming is under the IRA, there is a program called HERE, Home Electrification and Appliance Rebate, and it will be flowing through the states. I know that Alaska has applied for administrative funds to administer those funds to homeowners in Alaska. So it'll be administered by your state that knows, the circumstances there and knows the right requirements to put in place that are suitable for you. It's not just the federal government, just blanket sending things to every state that fit all. And then tribes, there's 225 million being allocated to tribes across the US. And some significant funds are being allocated to the tribes in Alaska. And those all apply to heat pumps. They also apply to other energy efficient appliances. And I can connect you with the details of those programs if you ask me later. There's I, I always talk about heat pumps, but I think it's really important to remember that heat pumps and every kind of heating and cooling appliance work better when your home is more efficient. So when you have good windows, when you've sealed up the drafts, when you've plugged all your air leaks and made your home very tight and insulated it. And so what sometimes that can be pretty expensive, but under this home efficiency rebate program, it's called Homes, there is some significant money being allocated to help people weatherize their homes. And there are organizations doing some very good work in Alaska. I think Alaska Heat Smart and Rural Cap and other folks that are available to help you with energy audits of your homes and making them better. And then finally, there's a rural energy program as well that's allocating money to rural areas. So I won't go into too much math, but I want you to understand the costs that the cost trade-offs that happen with a heat pump, because what we never want you to do is to get a heat pump and say, oh, it's 300% efficient, so I'm always going to save money versus the fuel source I currently have. That is not necessarily true, especially if you have very cheap gas and you have forced air. Sometimes in some parts of the country, electricity is actually more expensive. So when you go to consider a heat pump, take a careful look at what your current operating costs are. So let's take a look here. So operating cost is going to be fuel use times the utility rate. So if you just look at the gas furnace, say you've got a gas furnace and you look at your utility bill, you know how many therms you've used in a year, you know the cost per therm that your utility costs you, and you know how much you're paying for gas. And then estimate your heat pump operating costs. You're going to need the same amount of heating if you run it all the time, if you want to replace it. Electricity is cheaper per kilowatt hour, but you're going to use more kilowatt hours when you use a heat pump. And in this particular example, the heat pump is actually cheaper to operate to heat a home than is a gas furnace. But it's very important for you to look at your own utility rates and your own usage rates and make sure that you're not going to increase your utility costs. And I think I've got in this presentation you can pull up later, there's a very nice Alaska heat pump calculator that will help you with that. That was written by an Alaskan. And it really has all the efficiencies for heat pumps that are available. You can put in a model, or you can put in a COP that you know. You can put in your own utility rates, or it'll drop them down based on when you say what your address is, and it'll help you figure out whether you're going to save money with a heat pump or not. So just to recap that, because I know that was a lot, cost effectiveness varies with climate. The actual heating efficiency is going to vary depending on your region, depending on how cold it is there. Your cost effectiveness varies depending on what utility costs you currently have and what type of heating system you're currently using. And so this is the utility calculator that I mentioned to you before, that heatpumpanalysisnorth.com. It's also on the Chugach utility site now, as of, I think, just a few days ago. And that will help you to do the calculation that you need. And it was sponsored by all the folks listed there. So then another thing to consider is there is a point at which the efficiency of the heat pump gets low enough that it no longer makes sense to use it against the fuel price that you're currently using and the utility rate you have. And you can calculate that using that heat pump calculator. And then here's just an example here. So versus an oil heater and a certain efficiency of heat pump, when it gets to 8F, it no longer makes sense to use electricity to heat your home with a heat pump because of the cost of the electricity, the cost of fuel, and the efficiency. And so you can use that heat pump calculator to calculate that. And you can calculate the temperature and you can calculate the efficiency at that temperature. And a lot of people think about 1.9 is the point where heat pumps start being less attractive than fossil fuels in Alaska. Um, it really depends on how efficient the heat pump is. And I'm going to show you some exciting new technologies that are coming along. Molly, I'd like to ask you how I'm doing on time.
You're doing perfectly. All good.
Okay, great. And here's just a graphic of what that looks like. So here it is in Fairbanks. Here's the heat load. Here's sometimes it's 60 degrees there. Sometimes it gets down to minus 40 or below. And with the heat pump I showed you in the previous slide and the efficiency that it has, what it shows you that for 46% of the time, you're going to be economically better off using your heat pump versus your fuel oil in that particular case. And the same model, the same equation, the same trade-off is available for any heating source. So what it says is it's going to cost you more if you only used a heat pump. So a hybrid approach might be really good. Or maybe you say, well, where I am, it doesn't get that cold. I got a really efficient heat pump. I can insulate my home well, and I can like put up with slightly higher bills when it's minus 40 out because I want to just work with a heat pump. But even if you don't do that, you'll be saving money for a good portion of the year. And a similar analysis can be done with the minimum temperature at which the heat pump works. And so here's just a calculation that shows how, if you have a heat pump that only works down to minus 15, here's how much heat load you could take care of with that heat pump. So this isn't an economic analysis. This is an analysis of how much of your heat load you could realistically expect to take care of with a heat pump that only operates down to minus 15F. Okay, so now I'm going to move into how do you know what kind of heat pump to get based on your needs and your home and your climate and what you're looking at when you look at all these confusing numbers on the manufacturer's website. And so fortunately for extremely cold climates, the northeast part of the US has created a list, and this list has cold climate heat pumps on their list. They're certified. They have presented data that says we are cold climate heat pumps. We want your cold climate business. And there's a couple of criteria for being on there. One is you must be variable capacity. I didn't dig into that. We might dig into that in a future heat pump class. But the reason that heat pumps are so suitable for cold climates these days is because they're able to modulate. They're able to rise and fall with their compressor to meet the needs of the space. And we can dig into the technicalities of that in a future class. What you need to know is that nothing that is not a variable capacity heat pump is suitable for cold climates. So if you ever see an on-off non-variable capacity heat pump, do not put that in Alaska. The heat pump list treats ducted and ductless heat pumps. It has minimum performance criteria for HSPF and for both ducted and ductless heat pumps. It also specifies the efficiency that a heat pump must have at 5 degrees F to be on this list. And it also has certain minimum requirements for cooling efficiency. And you can also look at its performance and efficiency over a range of temperatures. So this is a list that this organization, NEEP, has already done the legwork for you. So if you go there, you can see many, many manufacturers who presented data to be on this list. There's a lot of popular brands, some of which you may have heard the corporate name of. Panasonic has been deployed above in the Northwest Arctic Borough quite successfully and is operating, I heard last week, extremely well. Mitsubishi also specializes in cold climates. Daikin is attempting to specialize in cold climates, and there's also literally hundreds of private label pieces of equipment that are rebranded out of usually out of Asia. Um, there's been a concentrated effort by the federal government to encourage the US manufacturing of heat pump and heat pump components, and that is slowly gaining traction. So keep an eye out for that. I think you're going to see a lot more components being made in the US. Always choose an Energy Star cold climate rated heat pump for Alaska. Never choose anything worse than that. And if possible, choose something from the NEEP list. And then finally, a really important thing is just if you have an HVAC installer in your area, ask them what they prefer because they're the ones that have put in units. They've come to trust certain brands, and maybe more important, if anything goes wrong, which it shouldn't, they're the ones that are going to have to service it. And if they're familiar with the brand that you're looking at, then you're going to be able to rely on them. Just a comment about sizing, because this is something that drives many of us crazy who specialize in HVAC. Bigger is not always better. Even your HVAC guy might tell you bigger is better. So your HVAC person might come and they'll be like, "Oh, rule of thumb, I think you're going to need 60,000 BTUs for your home because that's what your current gas furnace delivers." Invariably across the board, you do not need that much capacity. You probably need half of that for 99% of the year and 99% of the years. And I know you don't believe me because you live in Fairbanks, but this has been proven over and over again. The amount of capacity that you need for a home with a well-running heating system is not nearly the amount that you think it is. And there are tools and calculators and professionals who will help you do that analysis. But more important, if you put too big a unit in, it is constantly cycling on and off, even with those modulated units. And what happens is that creates excessive wear on the equipment and it will start to perform less well over time. So when in doubt, go more low capacity than you think you need when you analyze your bill. So here's a couple of exciting things that are coming along. Some of this might be a little wonky, but you'll have to tolerate me. I'm aware there's a new cold climate air source heat pump being tested right now in Alaska from LG. And they're claiming a COP of 5 down to some ridiculously low temperatures, that they can retain that level of performance. And some of your savvy Alaska colleagues are making sure that that's true because we don't want any claims that can't be supported for when it's the middle of winter. And if that's true, that could be very exciting. LG has decided to commit to cold climate heat pump performance, and they're partnered with the University of Alaska at Anchorage in order to do that. Another couple of really interesting things that are coming along are refrigerants that don't contain halogens. Halogens are things like fluorine and chlorine. And a couple of these that are really interesting are propane as a refrigerant. This is gaining a lot of traction in Europe, mostly for air to water heat pumps. So keep an eye out for that. I've seen some Senko, they're called SANCO2 air to water heat pumps coming in and they have the potential to operate on propane. And they're efficient, and those are, naturally occurring refrigerants. It's a great way to do it. Why they haven't caught on yet is because they are a little bit flammable. And so it's important to have the right controls in place to make sure we don't create more problems than we avoid. CO2 as a refrigerant is an up and coming possibility with some new innovations around it. So keep an eye out for that. And then controls. Controls are just getting smarter and smarter. There's controls that help with efficiency. There are controls that are responsive to homeowner comfort and occupancy that are really starting to get very sophisticated and very affordable. And those are something to keep an eye on. And then I don't believe there are any utilities that are doing load shifting in Alaska, but in other parts of the country, this is a topic of keen interest. So as more and more people are using electrical appliances, the utility being able to know how much load they have on the grid and to be able to sort of control that is something that's of interest in a lot of places. And I just want to mention that to you because it is a hot topic and an extremely interesting new novelty in heat pump performance. So this is the last section, and this is about placement and maintenance. So when you go to put a heat pump in your home, you're going to have to think about where you're going to put the head, if it's a mini split, if it's a ductless system, and where you're going to put the exterior unit in both cases, whether ducted and ductless. Typically in Alaska, where you have snowfall, it is recommended that you raise that unit up off the ground. Down in the south, they often put this right on a plastic or cement slab on the ground. Probably don't want to do that in Alaska. You want to get it up off the ground that it's higher than snow drifts and tuck it up under an overhang or build a little cover for it that will protect it from heavy snowfall, from dripping water that could freeze up on the coils and things like that. So this is an important consideration in cold climates. And there's a little visual of the cover. You can build that. There's also some ready-made ones that you can obtain. But just keep it from being buried in the snow because you're going to lose efficiency rapidly and may even end up damaging the coils if they freeze up. One thing about heat pumps is when they're running to heat your home, those coils get very cold and sometimes they frost up. So the clever heat pump manufacturers have implemented a thing where just for a few minutes, they run in reverse and they defrost the coils by pushing the heat back out again. And when that happens, water drips. And so you want to just make sure that it's not dripping on the sidewalk right outside where your grandma is going to walk and then slip and break her hip. So keep an eye on condensate management, keep an eye on wind protection, and keep an eye on avoiding burying your heat pump exterior unit in snow drifts. Here's just a little bit more about snow protection. We don't really need to get into that. A couple of other things is protected from animals, protected from squirrels and I don't know, caribou getting in there. And consider noise and vibration concerns. Some people are very sensitive to the sound of the compressor and the reversing valve. And I personally am not. I have one mounted to my bedroom. But if if you've got somebody in your home that doesn't like any noise when they sleep, then probably don't put that compressor right on the wall outside of the bedroom. Put it maybe in the main living area or outside the kitchen. And then maintenance. Properly installed heat pumps will last more than 20 years without maintenance. The ones in the Northwest Arctic borough, the Panasonics, those have been operating for 8 years without any problems. But a little bit of maintenance is necessary, and it's not onerous at all. But there's a filter in the air handler of a ductless mini split heat pump that you want to pull out every once in a while and rinse off in the sink and clean. And then the coils on the exterior unit of both types of units. Make sure if you've got, I don't know, pollen or leaves or something that can build up in there, just go out and give them a good dusting off or hosing off every once in a while, maybe even once a year. And even then, it might not even be a problem. You could go for years, but just give them a visual check once a year and make sure that those things are clean, so that you don't end up with low airflow and with decreased performance. So this is not a lot to have to do to keep a unit heating you and then cooling you briefly in the summer for 20 years. These are rugged little pieces of equipment. And that's actually all I have today. I just want to take 2 quick slides to tell you why I am with EcoSnap and visiting y'all in Alaska and talking with CCHRC. What we've noticed is that in many areas of the country, it's difficult to find HVAC technicians, and sometimes they're very expensive when it comes to putting in heat pumps. And we identified that a lower skilled way to connect the refrigerant lines, the electrical, and the condensate line saves both time and money and makes heat pumps more accessible to more folks. So we've developed an engineering solution that you can see right there. It's a lever that pulls together the refrigerant couplings that makes it a quick connection. And not only does it make it more accessible, lower skill, and cheaper to install and faster, but it also makes it more foolproof so that those connections are made in a way that they don't leak and degrade performance rapidly. So it ensures or attempts to ensure, I never want to say 100%, but it brings us closer to assurance that they have in fact been installed properly and you don't have to worry about it. Then you've got them for the next 20 years. You've got a great piece of equipment that will continue to perform for you for a long time. We're trying to fill that. Here's just a visual of what a traditional install requires: fabricating fittings in the field, charging and evacuating the refrigerant lines, and we've taken out many of those steps and compressed it. We exclusively do ductless mini split heat pumps, and so we don't have solutions for all of your heat pump needs, but that's why I'm here. I'm passionate about it. I'm passionate about everyone having access to affordable heating and cooling solutions. And it's been a pleasure to share my knowledge with you today. And now I'd like to take questions.
Thank you so much, Dr. Diana. That was a wonderful presentation.
Um,
Amazing to hear. Loved all of your graphics. You got some awesome visuals. So now we'd like to open up the class for questions. Feel free to raise your hand in the virtual hand or unmute yourself or type a question in the chat, whatever is easiest, and we'll be monitoring that.
Erin, I'm not sure I know how to answer your question. I think if you're asking about the crossover temperature, I think that depends very much on the cost of gas in your area. And if you go and play around with that calculator, it's so intuitive and easy to use that you'll rapidly find at what point there's a payback and there's an economic crossover. We could talk about it offline. I'd be glad to chat about it. Fred, yeah. I kind of glossed over that. Thank you for asking. So our heat pumps, EcoSnap's heat pumps, are on 115 volt units, specifically so that they can be plugged in because we identified running the electrical as an extra cost that wasn't required for homeowners. Now, having said that, that limits us to 12,000 BTU or less because the larger units require higher voltage. And it is possible that at extreme cold temperatures, they'll require too much amperage. And so in those cases, you would certainly want to go with a 208, 230 and wire it directly to the panel, or possibly put a specific outlet in for that. So for most of your higher capacity units, like an 18,000 BTU or 36, you will need the 208, 230 power. Any other questions? Yeah, so I don't think so, Aaron. And I need to verify that every manufacturer has surge protection and startup protection. I have heard from some of your folks that are working in the Arctic that heat pumps can be damaged by the power going out. But I honestly think that all the modern heat pumps are designed with protection like that. The only disadvantage is, unlike firing up your wood stove or your Toyo stove, a heat pump doesn't come up instantly. And so you're going to have to wait while it does its thing with the compressor and gets the refrigerant moving. And so it'll take a little bit of time until it comes up after a restart. I know that Phil Kaluza told me that they ran a heat pump and just wanted to see how low it would continue working. And when it got down to minus 40, it shut down, stopped running. And then as soon as it warmed up, the unit came back on and worked perfectly, and there was no damage to it. I can't guarantee you that every manufacturer has that ability. I'm continuing to study the situation and looking at all the different manufacturers and making sure they're all suitable for cold climates. I would dare say that anything that's on the NEEP list, you might want to trust, but I promise to keep verifying that and get back to you guys. Um,
We're having a lot of questions in the chat.
yeah, I'm
Jim, do
looking
you
at
want to go ahead?
Ben, I'm going to answer your question next, and then Kathleen, I'll get to yours. I don't know. I'm tracking the status of each of the states. New York has already begun rolling out rebates. And Alaska, the last time I looked, was at the point where they were applying for the funds. And I know that Ah, who is it? Molly and Rosa, do you know who's administering the funds?
Yes, it's the Alaska Housing Finance Corporation and
That's
the
it.
Alaska Energy Administration, AEA. I think I got that acronym right.
Yep.
And unfortunately, there's been some delays, and I think that they just announced we should expect to see the full program sometime in the second half of 2025. So that's a bit disappointing. We're going to be waiting a little while longer, but someday
I
soon.
would say you're not really behind most states, to be honest. I mean, a couple of states, you know, the notable big hitters, right? Like New York and California, they jumped right on applying. But I would say the vast majority of states are exactly where you are at applying for those funds and getting them rolled out. And, you know, to be fair, I think it's really important to roll them out properly for your state, right? And to understand all the best ways that it's gonna get deployed. Because if we do it wrong, that just that doesn't help anybody. I want to look at your question, Kathleen. Separate heat pumps for heating and hot water to replace Toyo stove, for example. I actually don't know that much about Toyo hot water stoves. We have a government grant in place to integrate our heat pump with a Toyo stove, so you can switch off between heat pump use and Toyo stove at a given temperature or performance level. And I expect to report out on that in the spring. Um, in most cases, people do choose to do two separate heat pumps, a heat pump water heater and a space conditioning heat pump. Yeah, Fred, I think you're probably right. Do you want to comment on your experience with that and give some insight that I don't have? He does not. Okay, you're welcome, Kathleen. Any other questions? I did skip the slides on heat pump. There are heat pump water heaters that are fairly well developed technology. Oh, okay, thanks, Fred. Um, and those are pretty cool. And then there's also heat pump clothes dryers. I don't know how common gas clothes dryers are in Alaska. They're relatively common in Colorado. Um, but my understanding is heat pump clothes dryers work quite well as a substitute for a gas dryer.
All right. Well, thank you again, Dr. Diana, and thank you to GVEA for sponsoring tonight's presentation. Again, if you did enjoy this class, we have two more classes left in the Fall Clean Energy Series, Solar Power next Tuesday, the 15th, and then Biomass Energy the following Tuesday, the 22nd. We just dropped that link in the chat, so feel free to go there to learn more or to register. Thank you again for attending tonight's presentation and have a lovely rest of your night, everybody.